Hello everyone, this is Kalpa here, Azure Technical Trainer from Microsoft. Today we are going to discuss about implementing pipelines and Azure Machine Learning using Python. We will basically understand how you can automatically trigger a pipeline which does data processing and model building for you. So without any delay, let's deep dive and understand how we can go ahead and implement this. Enter pipeline, which has two steps. One does data processing and the other step does the model building. We are going to trigger this whole pipeline based on any kind of event or based on schedule reoccurrence. And you can also go ahead and run data processing in its own environment and cluster. And you can also run model building in its own environment and cluster. In case if you want to do your data processing in your CPU machines, you can go ahead and do it independently. And in case if you're going to build your models using GPU machines, in case if you're trying out deep learning models, then you can go for GPU clusters. So this is how you will be able to independently execute these modules in its own environment and clusters. You can also pass arguments to these scripts independently. But whereas if you see, these two steps are sequential, wherein only once the data processing is done, only once we have the clean data, we can take that clean data and build the model. So for this, we will also learn a concept called creation of a temporary folder using pipeline data object. So this is where we will create a temporary folder. What we will do is we will do data processing and we will clean the data and we will store the clean data in this particular temporary folder. And the step 2 here, which is model building, this particular step will take the input from the folder, temporary folder wherein you have saved your clean data. Now let's deep dive into the code. If you see over here, at first we are connecting to our workspace. We are making use of workspace object from Azure ML core, and then we are connecting to our workspace. We are cross-checking whether we have connected to the right workspace. And if you see over here, this is where I have launched my Azure Machine Learning workspace, and my workspace name is DP100. And hence here it shows that I'm connected to DP100 workspace. Just for your reference, DP100 is a course, and in case if you're interested more on learning about Azure Machine Learning, you can go and do this course. Now let's go and see how we can access our dataset. We have already created a dataset in Azure Machine Learning called diabetes dataset. So we are just cross-checking if our dataset is there or not. In case if our dataset is there, it says dataset already registered. Since we have already created a dataset, you can see that it says dataset already registered. In case if you have not registered your dataset, then it will take this particular path where it will go and create tabular dataset for all the CSV files that resides within diabetes data folder. So you will make use of tabular dataset when you want to create dataset for structured data. Next, you can see over here we are registering our dataset. Now that we have created our dataset, we go ahead and register our dataset with the name diabetes dataset. We give some description to it and we tag it with so and so name, keys and values. So if you see over here, it's required for you to go ahead and register your dataset because our pipeline will always be pointing to the latest version of the dataset. Similar to this, you will see further, you can also go and register your models. You can also go ahead and register your created environments. So this way, anytime your pipeline will always be pointing to the latest version of be it dataset or be it model or be it environments. So now that we have our dataset created, what we will do is we will go and understand how we can go ahead and write scripts for data processing step and for the other step that we had discussed, which is model building. So we are going to create two different scripts for data processing and model building. and after that we will also create environments and cluster wherein these scripts will run. So let's go and understand that part of the code. So see over here, we have created an experiment folder wherein we are going to keep all our scripts. Now we will see how we go ahead and create script for data processing. We are making use of prep diabetes file wherein we are writing our script which is placed within the experiment folder. We are passing parameters to our script using Python script step, which we will be seeing in a while. Here we are passing our dataset, and we are also passing the name of the temporary folder wherein we need to save the cleaned data. Next, we are getting the run context of this particular experiment. We are accessing the datasets. We are making use of 2 pandas data frame in order to read the tabular dataset. Once we have our data, we are counting the number of rows within our data and logging it as a metric called raw rows. And you can see over here we are applying data processing, like we are removing all the null values, and we are standardizing our numerical columns using min-max scalar. We are once we have our min-max scalar object, we are fitting and transforming our numerical columns. After the processing, we are checking how many number of processed rows we have, and we are logging it as a new metric in our experiment called processed rows. Now that we are done with the processing, now that we have the clean data, we are going to save that clean data in the temporary folder. So where is this temporary folder? This particular temporary folder is the folder which is passed in our Python script step, and we are making use of this temporary folder which we are referencing as save folder, and this is where we are saving our clean data set. As you see in the pipeline workflow that we had explained, now that you are done with the data processing part, you'll be saving the clean data inside the temporary folder. Now next we will understand how we will take the clean data from this temporary folder and we build the model building. Now we will be writing the code for model building. For that we are creating a Python file called traindiabetes.py, which we are placing within the experiment folder that we had created earlier. And you can see over here we are making use of scikit-learn libraries, we are making use of pandas and numpy for the model building. You can see over here we are making use of decision tree classifier using scikit-learn in order to build our models. So let's understand the code here. You can see over here we are making use of the parameter called training folder. This is the folder from where we are accessing the cleaned data. So once we access the clean data by making use of pandas read CSV in order to read our clean data that resides in the temporary folder that we had created. And now once we have the data set, we are going to split our data into train and test. We are keeping around 30% of data for testing and remaining 70% of data for model building. So let's try to understand what model we are trying to build here. We are keeping the code simple because it's just part of the demo, and you can see over here we are making use of decision tree classifier and fitting decision tree classifier on our train data. Now once we have the model, we are trying to predict our test data using the model that we have created, and you can see over here we are once we get the prediction for the test data, we are using the predicted results and we are calculating the accuracy. Similarly, we are also getting the AUC score as well. So now that we have got our metric, what we will do is we will plot the ROC curve, and then we are going to save our model in a folder called outputs, wherein we are storing all our experiment outputs with a name called diabetesmodel.pkl file. So this is a model which is saved in outputs folder in our experiment, And from there, what we will do is we will take the model and we will register the model. That's what we had earlier discussed. In case if you want your pipeline to always point to the latest version of the model, we need to go ahead and register those models. So now that we have our model placed in output folder, we are going to register our model. So while registering, we are giving the name as diabetes model, and we are tagging with a name called key value called training context and pipeline. We are also getting the properties of the model called accuracy and AUC score, using which you will be able to later analyze how that particular model gave you the results. So now that we have our model registered, the two parts that we had discussed, one was data processing and saving the file within the temporary folder is done, and also accessing the data from the temporary folder and model building is also done. So now let us see how we can create the overall pipeline and trigger this pipeline. Now that we have our data processing script and model building script, we need environment and cluster to run these scripts. So for that, we are going to create the compute target and we will also create the environments. In order to create the compute target, you can make use of compute target and AML compute from Azure ML.core compute. You can see over here, we are going and creating the configuration using AML compute provision configuration, wherein I am saying I want machine of so and so type and I want 2 such nodes in my cluster. So once you provide your configuration using AML compute, you're going to create your compute target by specifying what should be your cluster name and within which workspace you want to create this particular compute and what are your compute config. So basically you get the compute config from here, which you had defined using AML compute provisioning configuration. So now that it's getting created, let's wait until it finishes creating the compute target. So once it completes, then we will go ahead and create the environments. You see over here, we are making use of environment from Azure ML core. So using environment, we are creating an object of environment and we are making use of Conda dependencies in order to install our pip packages and Conda packages. If you see over here, we are making use of scikit-learn, Azure ML, data prep pandas, all of these matplotlib, all of these packages that is required for our script to run. So once we are done defining our packages, now that we have the list of packages that we want to create environment for, we will go ahead and create our environment and we will also register our environment. Now I can see that we are registering the environment because in future, in case if you update the environment, always my pipeline will be pointing to the latest environments. Once you have defined your environment, you're defining your pipeline run config, wherein you're specifying this is the cluster and this is the environment wherein we need to run the pipeline. So now that we have data processing script, model building script, and we have compute target for our scripts to run, and we have environments for our scripts to run, let's go and create the pipeline. In this demo, we are making use of same cluster and environment in order to run both the data processing and model building script. Whereas in case if you want different compute target and environments for data processing and different compute or target and environments for your model building, you can do that as well. So let's try to see, understand how we can go ahead and create the pipelines. We are creating the pipeline by making use of Python script step. So at first we need to create the steps that we have in our pipeline, and finally we will create the pipeline object using these steps. So let's see what are we doing here. So basically, by making use of Python script step, we are creating a step for preparation data. So this is a name we are giving for data processing, and we are specifying which is a script we need to run in this particular step. So this was a script that you had created for data processing. And you can see over here, this is where we will be passing in parameters to our script. We are passing our data set, and we are passing the temporary folder wherein we want to save our cleaned data. So how did we create this temporary folder? We made use of pipeline data object in order to create our temporary folder. See over here, we have given the name of a temporary folder as prepped data folder, and we are storing this prepped data folder within the default data store within our workspace, and we are referencing it to as prepped data folder. So this is the folder name which you will be specifying in the outputs, wherein you are saying that whatever is the output from this particular file will be placed here in this temporary folder, and then you are also specifying whatever is there within this particular folder will be passed as input to my model building step. So this is how, though the steps are running independently, they will be able to share information, and in case if they are sequential, you can go and make use of these temporary folders wherein you will access the data from your previous steps. Here you are saying in this particular step, this is a script that I want to run for building my model, and this is where you're also passing this as argument to your script, because your script needs to access the data from this temporary folder, and you're also saying this is where I'll be accessing the input from my previous step. And you're specifying your cluster and config, wherein you have specified your environments as well, which will be used by your script experiment while it runs. This way you will be able to create each step in the pipeline wherein it has its own arguments and it has its own compute cluster and run config details. Similarly, you can see for the model building step, it has its own script, it has its own arguments, and you can specify its own cluster and environments. So now that we have defined our Python script steps, we will go and implement the pipeline. So let's see how do we do it. You can create pipeline by just making use of pipeline object and say this is the workspace wherein I want to create the pipeline, and this is where you're specifying your pipeline steps. You can see over here we are defining the pipeline steps inside this reference, wherein we are saying this particular pipeline will have two steps, one which does the data processing and other one which does the model building. That you have your pipeline, you're going to create an experiment which would be your pipeline experiment. You're creating an experiment within your workspace with the name MSLon diabetes pipeline, and you're submitting your experiment with the pipeline that you have created so far, which you have defined here. And you can see we can wait for the results and see the results within the notebook itself by using run details widgets. We can wait for the pipeline to complete executing, and once it is done with the execution, we can go ahead and see the results. We can also see the results within Azure Machine Learning Workspace run history as well. So in a while, I'll be showing you that. So once your pipeline runs, we can get the metrics of a pipeline run. We are making use of run.getMetrics, using which we are accessing the metrics. If you see over here, we had two scripts that got executed within this pipeline. One was training and registering, and other one was data processing. So for each of it, we had logged few metrics, and you can see over here, we are getting accuracy, AUC score, and ROC plot. If you see over here, this is the plot we had just created, which is a PNG file. You also get to see that within the run history. And you get your processing metrics, wherein you had logged raw rows, and also after removing your null values and standardizing your columns, again you went and checked for processed rows. So these are the two metrics that you are logged while creating your data processing script, and you're able to see those. So now that I've seen the metrics of our pipeline run, we are going to see the list of models that are registered within our workspace so far, and I can make use of model from Azure ML core, and you can access this model.list within your workspace, which will give you the list of models that you have registered so far within your workspace. So the latest model that we have created is pipeline model, wherein we have got 88% of AUC score and around 89% of accuracy. Going further, you can keep improving your models and register with the same name. So this way your pipeline will always point to the latest version of your model. So now that your pipeline is ready and running successfully, we can go ahead and publish our pipeline. So that's what we are doing here. We are making use of publish pipeline to publish our pipeline with the name diabetes training pipeline, and we are giving so and so description. So once we publish our pipeline, we can access the endpoint of our pipeline using published pipeline.endpoint. Now that we have this endpoint, you can make use of this endpoint to trigger the pipeline anytime you want. So we can trigger our pipeline using requests, wherein we are passing the pipeline endpoint and authorization header and the experiment name. And you can see over here we get the run ID for the pipeline experiment that we just ran. So once you have this run ID, you can make use of this run ID to access the metrics, to access the logs as such. You can also schedule the pipeline using schedule reoccurrence, wherein you are specifying, I want to trigger this particular pipeline every week, so and so day of the week and so time of the. You're giving the description, you're giving the pipeline ID, you're giving the experiment name, and calling this particular schedule reoccurrence that you have created to run this particular pipeline every week on Monday at so and so time. Now that we have created this schedule, you can always see all the list of schedules by making use of schedule.list within your workspace. And I can see over here we have scheduled this particular pipeline to run at this frequency. Now that you have created your schedule, you can always access your latest runs by making use of the experiment name that you have just created, and accessing the runs by making use of 0 over here, which will always access your latest run. And once you have your latest run, you can make use of get details to get all the details of your run. This is pretty much how you can create your pipeline using Python. Now let's just go and see the results here in experiments. So we had given the name of the experiment as MS Learn Diabetes pipeline. And you can see over here, let's go and check the latest run and see the metrics details as such. If you see over here within the graph, it says we took the diabetes dataset, processed the dataset, and built the model on our dataset. And you can see over here for each of the steps that you had in your pipeline. We basically had two steps in our pipeline. One was data preparation and other one was training the model. For each of the steps, you can see its corresponding run ID. So let's just go and select its run ID, and you will be able to see its corresponding metrics, wherein you can see what are the metrics that were logged within this particular script, and you can also see the corresponding logs of this particular script. So that's pretty much what I wanted to discuss here in this session about pipelines. Thank you so much.